Find the missing side lengths. All right, I have a triangle. That's 45 degrees. That's 90 degrees, which means you're 45 degrees as well. Now, this is a special case triangle called the 45-45-90 triangle. It's called 45-45-90 because the angles are 90 degrees, 45 degrees, and again 45 degrees, which means it's isosceles, which is good because whatever one leg is, the other leg is exactly the same. If I'm given a leg, what I can do to find the hypotenuse is take that leg and multiply it to the square root of 2. So if you're thinking, this is pretty simple, just take a leg and multiply root 2 to it to get the hypotenuse, I'm done. Great, except this one's not that simple. See, I'm given the hypotenuse. I need to find both legs. X and Y are going to be the same thing. So once I find X, I have Y. The problem is I'm starting out with a hypotenuse. So if I'm given a leg and I multiply square root of 2 to get the hypotenuse, then in order to get the leg from the hypotenuse, I divide by the square root of 2 because I'm working in reverse order. Now, when you have a square root and you divide by a square root, we can shove 2 off to the side and divide both of these guys within the single square root. So you get 6 divided by 2 inside the square root. Last time I checked, 6 divided by 2 is 2 times the square root of 3. And so my X and my Y are both going to be 2 times the square root of 3. So there are times where you use special case triangles like this one, and you're given the leg, and it's easy. When you're given the hypotenuse, you have to work in reverse, which means you divide by the square root of 2. And in our case, it still ended up being a fine number. If you're like, oh, let me whip out my calculator and find out what that is, don't. Okay, whenever you're dealing with right triangles, you're going to see square roots quite often. Don't lose sleep over it. I certainly won't. Neither should you.